All right, welcome, welcome. So, first and foremost, I promised, before I get into this, I promised to do this. There's a special lady I love very much in the audience. I promised to introduce her, the youngest developer in the room, my 5-year-old daughter, Annika, over there. So let's give her a hand. So that's awesome. She's working on getting on Lightbot, if y'all have looked at that. So today we're going to be talking about the model of continuous delivery, and we're going to focus on an implemented example that takes a web application on top of SQL Server, so simple application topology, and goes through every concept in the DevOps model all the way through Azure, and the implementation happens to be serverless. We have 3 implemented environments. We provision those environments automatically from ARM templates. Everything is running on VSTS and automated completely through. So I'll be able to show you. Now we only have a little bit of time, but I'll go through how we set up the source control, builds, releases, and production monitoring with application insights, and implement all of the concepts in the model. And the model is important because I'm showing you one example, but you're going to have to go take it and apply it to your applications, which look very different, and some may have 37 different running processes across 12 different server types, who knows where, and some of yours may be, one 15-year-old application with everything in it running on top of 2 database servers with cross-server store procedure joins, and you still have to implement these concepts. So I'm going to focus on that and how this intersects with a cloud implementation with examples in Azure. So a little bit about DevOps, just to run through it. DevOps is the last mile of Agile. How many people are using concepts from Agile software development? Okay, so about half the room. Let's see, about 2006, I think, there was a group in town called Agile Austin. Has anyone ever gone to an event from Agile Austin? I helped start that group way back when, and I started getting into Agile in 2005, and continuous integration was early, but DevOps is the last mile of Agile, and I'm going to get into that a little bit, where we can move quickly and deliver incremental value. By way of introduction, if I've never met some of you, my name is Jeffrey Palermo. I've been a Microsoft MVP for a while, and I've written some books, mostly in the .NET space, and I run a software engineering firm called ClearMeasure. We focus on Visual Studio-based custom software, any version going back, bringing it forward, getting it prepared for the next decade, fixing the issues, making it stable. We're doing lots of automated deployments for existing systems, moving a lot of those into Azure. Whatever the issue is that holds them back, that's our focus. And DevOps is definitely a group of modern methods that our industry has learned and is learning how to apply, and so they're proving to be very, very useful for new systems, but even systems that have been around for a long time. There's some reasons on why we care about this whole topic. Every one of us that's been working with custom software has experienced a lot of pain in the past. Show of hands, who has lost at least 4 hours sleep with a software deployment at some point in your career? Oh, come on. Everybody's hand should be raised up. Now, I'm 4 hours. That's generous. How many of you have lost like a whole weekend? Don't put up your hands. We have pain from the past. Things have gone wrong. And businesses, the folks in the business who are paying the bills but don't really understand in the ins and outs of the technical issues, they just look and say, oh, what's going on? How do I solve this problem? And so as an industry, we still don't have a very good track record for system stability, project success, and so there's a lot of improvement that our whole industry can make, and DevOps is certainly has promised there. So we all want the same thing. This list is short. I try to abbreviate it. We all want stability. We all want quality. We don't like surprises when the system doesn't do what we expect it to do. And we all want speed of delivery so that when users or stakeholders ask for a change, we don't have to say, oh, it'll be a couple of months, because when we touch the thing, 3 other things break. All right, so there's some things that we can do here. One is finish implementing extreme programming. As an industry, extreme programming was the harbinger in 1999 that gave birth to the Agile Manifesto in 2001, that has sort of given birth to Scrum, that has really largely impacted the entire organization. And one of the tenets was to deliver in many quick increments to users. Not to QA, to the actual people using the software, okay? And somewhere along the way, a chunk of the industry has gotten sidetracked to where if they do sprints, the delivery of the sprint is delivered to a QA team and not to the users. And then we look back and say, wow, how often are we actually delivering to the users? Oh, we're still only doing 4 actual releases per year, but we said we were doing Scrum. How do we get off track? And don't raise your hands if that resonates. But the canonical answer of what is DevOps is development and ops coming together. Here's the interesting thing. The ops people, if I'm over here on the edge of my blue tape for the camera, the ops people are saying, you know what, look at what we've done. We've done virtualization and this cloud thing and this automation thing, and we can spin up servers with the running of a shell, and I can ship log files, and we've done so many advances, we built the cloud. Those developers, man, their code's so buggy, they need some help. You know what? We need to go over and help those developers. And so ops starts walking over to developers. In the meantime, the developers say, wow, look at what we've done. The Agile Manifesto, Scrum, microservices, all these good things we've done in software. Man, but these ops people, they just can't even keep the servers running. You know what? We've got our act together. Let's go and help them. They need some help, and they start walking over. So there's different competing perspectives that ops and dev are coming together, but it's a good thing that we're no longer thinking, and the people who are participating as early adopters of this DevOps concept are thinking of that we're coming together and addressing these concepts as a whole. That we say, you know what, the mainframe era that separated dev and ops was a bad idea. Let's undo that, and let's, as an industry, let's realize that if we deliver a system, we're responsible for actually operating the system, and it's not two concepts. In the mainframe era, multi-user terminals, that actually created the division. If you look back now, if you didn't actually live through when that started, you had these multiple terminals, and you had the mainframe, and now you had a multi-user system. And so one person on a terminal could do something, and then it would take down the mainframe and crash the mainframe. And so every user connected to the mainframe would go down. And so that was a bad thing. And so then someone had the bright, you know what? We're going to make somebody in charge of keeping this mainframe up. And they said, well, shoot, I need to start restricting what these users are doing because they can take down the mainframe. So they start creating rules, and they start creating boundaries. And now there needed to be a group of people who was responsible for making sure that nothing bad happened on that mainframe to keep it up. All the while, programmers were users. Most of the users in those days were programmers, as opposed to my mother. And so there were all these terminals, and they were doing things that could take down the mainframe. And so you had these competing interests because architecture of that type of computer, that type of server, and now the division started with the people who wanted change and the people who were hurt by change. And so then our industry divided. Whereas now we had the elements of coming back together and undoing that divide that the mainframe era started and largely carried us through mini computers just because that's the way the industry's done it, right? You got ops and dev, and you need it there, right? Well, the cloud is enabling a lot of things as well, but that whole paradigm is unnecessary anymore. And so a lot of the forerunners that have created the DevOps movement and the first movers, certainly Facebook, Spotify, Netflix, and now Microsoft and Google and Amazon, they're sharing their stories where they're saying, you know what, yeah, we used to have a group of developers, and we used to have a group of testers, and we used to have a group of IT pros and sysadmins. No. One group, and if you build it, you run it. And so they're all merging their groups back together, and it truly is changing the structure of organizations and companies. So anyway, that was a sidetrack, but let's get on with this. So I'm just going to touch on this first anti-pattern of DevOps. If you deploy software manually, that's the biggest. If you can automate your deployment, even if your software doesn't have any tests currently, even if you don't have any static analysis, if you can just make a small change and get that down the road, now you have the foundation to start putting more of these things in place. Okay. All right. So I'm going to touch on the first principle of the Agile Manifesto. It says our highest priority. There's 12 principles behind 4 values. Okay. If you go to agilemanifesto.org, you can see this. The first principle is our highest priority is to satisfy the customer through early and continuous delivery of valuable software. You know what? That concept is kind of still the thing we're trying to do, right? This DevOps movement doesn't replace Agile. It doesn't say everything's different, everything's new. It's a new set of technical methods and principles that help us do this thing even better. It's a continuation, a progression. Now, this right here that you cannot see very well, this is the model that we're going to go through. Okay, I'm going to zoom in, and this is the model that we're going to go through. If you would like, the full-size Visio of this, get with me afterwards. I'd be happy to give it to you. If you don't have a plotter, get with me. I'll be happy to even print out the full architecture D size version so that you can post it in your office or where you work. Happy to do that for you. But I'm gonna Windows Zoom, and we're just gonna go through the model. Scrolling down, these are source control branches that I'm gonna come back to. Okay. Now we're not gonna go into this text, but the first part of DevOps is your private build. Nothing to do with the server. It's does every person on your team go through the same set of steps to say, am I good to push new code to the source code repository? Because I'm so used to it, I'm gonna talk in Git terms, but if you're using Subversion or Team Foundation Server or Perforce or any star team, any version control, I'm just gonna use the Git terms. Before you commit code, you have to know, am I gonna mess somebody up? Now, if you use topic branches or developer branches, then okay, it's just yours. You can commit all day long, and you're not going to mess anybody up. That's a mechanism there. But the private build should be a minimum set of steps where, okay, I'm going to do this every time and I'm going to run this script in order to make sure it's okay for me to push something up, so that if my teammates pull it down, I don't break them. Okay, that's within your team. Then, once someone does push code to the source control server, the continuous integration build, CI build, runs through a set of steps to make sure that it's good, compiles, runs tests, configs, stamps a version number on it, and creates a releasable candidate, a release candidate, packages it up. Then, now we have release candidates, we store them. In the Microsoft space, we store it in a NuGet server. I'm going to talk about that a little bit later. Yes, that did just come through in the last couple of years, so if you're not on it, it's just, that's kind of what it is now. Then the initially deployed environment, this is a first line dev test environment, then a QA environment, then a staging environment, and then production. In some cases, QA and staging can be combined. I'll talk about that in a minute. And then production. And then after production, it doesn't matter if you're purely a coder. You can't ignore this. Monitoring is part of the DevOps model. Okay? If you can't monitor it, if someone said, hey, I was on here and I had a problem, and you can't just pull something up and say, oh yeah, I see that you were on there, and I see that you went through this set of pages, and I see that you stopped here. Okay, yeah, I can see your problem, user. I understand exactly what you're doing. Let me dig in and help you out. If you don't have that kind of visibility into your own software, then there's a gap here that you can fill. Because the tools exist today where you can get all of that telemetry, and it's pretty darn easy. So monitoring is super important. in the DevOps model. And then the tool chain, I'll zoom in here. The tool chain is pretty darn simple in the Microsoft space. Visual Studio Team Services, which has their source control, your build, your automated deployments, your package management, has NuGet Server built in. Azure is your environments, and Azure includes Application Insights, which is monitoring, as well as the ability to create an operations management suite resource so that you can suck telemetry from all of your systems, no matter how many environments that you have. So in the Microsoft space, there's some pretty good consolidation, even though there's a lot of concepts here. And we're going to go through those quickly. Okay. So I'm going to have to represent here. Okay. All right. Continuous delivery. Who has seen this book in real life? All right. Yes. Booyah. All right. If you haven't, meaning everybody else, read the book. This book came out 2009, I think, and I believe it was 2010 at a DevOps Days conference in Europe that is credited for coining the term DevOps. So this book came out just a year or two before anybody was saying the word DevOps. So we had a candidate at work talk about, oh, when did you first start doing DevOps? And I think it was about 2005. And we let him talk for a little bit, and we didn't hire him. So DevOps, nobody said the word DevOps before 2010 that anybody knows of. But continuous delivery, there's a lot of these concepts that have been published since 2009, and there are principles and practices, and I listed them here. They're right from this book. But some of the ones I'm going to highlight don't come from technology, and one of the ones on the right bottom. If anything fails, stop the line. That was learned from the Toyota production system, and that's largely been accepted. That I haven't encountered anyone who thinks that's a bad idea. But other ones that are still not quite adopted, that are really impactful, are building the binaries only once. Now let me touch on that for a second. The continuous integration build is responsible for producing release candidates. And so only the compilation only occurs there. We package up binaries and everything necessary for the application to be installed and run in a set of NuGet packages, and then we promote them down the line. Okay? So an anti-pattern of this would be if it's time to go to staging and going back to source control and then calling MS build again. All right? Okay. Okay, now let's go through the model in more detail. And I'm going to show you the example, so I want to go through this pretty quickly. The first part is how we organize the work. If you happen to be starting a new project, plan for iteration 0. That's a concept that's been talked about in the Agile world for forever. But the goal, and even if it's not day one, the goal is to get your new piece of software in production on the first day. If you can't do the first day, make it the third day. You know, even if it takes a few days, get it in production on day one. Now, guess what? That piece of software is not going to have any features. It won't even have a login page. It will be this empty shell of your prototype that you think is going to be your starting version, but you will actually have the ability to run it. And if it only returns a page that returns 200 OK, that's enough. But you are in production, you have your sequence of environments, you have your build up and running, you have the entire DevOps pipeline, and now everything is incremental. So an issue that Agile teams have struggled with for new pieces of software is when to start iterating, and it's too common for the team to start out with some type of waterfall phase where you have to amass some level of feature set or system capability before getting into increments. And unfortunately, it's too easy, if you adopt that model, for you to be several months down the road and still haven't gotten into any iterative cycle. And so if you can just say, okay, I'm not working on any features, I'm getting into my iterative cycle right away, then that is going to enable everything. Because until you have the right scaffolding and process support, you can't actually move quickly. So do that right from the start. And that's in planning, in your work planning. So break down whatever steps is necessary. In version control, This is a sample structure of a source control repository. You don't want to put your Visual Studio solution right at the top, because then your top level scripts, build scripts, they kind of get crowded with your solution file. So it's been like this for probably at least 10 years from what I remember, that an SRC directory is a convention that's used across all kinds of platforms. And so start out your new version control repository, put an SRC folder, and in there put your Visual Studio solution so that you have a top level to put things that might go across solution and some other tools. Okay, and then make sure to include absolutely everything in version control. Git makes it possible to go backwards in time. There are times, and it doesn't matter who you are, there are times when I will be working on something and the software will just stop working. It'll be completely broken. I'll say, man, it was working an hour ago, or it was working yesterday. I have no idea what happened. I bang around a little bit. I have no idea what happened. It's not working. If we can go back to the last time that it was working, that is a huge enabler, because some problems don't need to be solved. I don't need to actually figure out why it stopped working. If I can just go back to this morning and, okay, now it's working again, well, now I go forward. And so there was a time in my career where, even though I knew I could do that with even Subversion, even SourceSafe, way back when, my pride, I wanted to figure out why it stopped working, and I just waste a day, and it's not necessary. Now, who's using NuGet package restore? It's on by default, so pretty much, unless you explicitly do something, it's going to be there. And I've had lots of conversations with the Microsoft product team about this, and NPM in Node suffers the same thing. Architecturally, from a paradigm perspective, when you use a package manager, when you adopt a package manager, you go from a place, let's remember when a package managers didn't exist. We had a source control repository, and the DLLs that we chose to reference, we downloaded them from wherever online, SourceForge perhaps. We got the DLL, and we downloaded them, and we referenced them, and they were in our version control repository with our application. Well, now these package managers come out, and now, because of the way they work, we think, oh, well, I don't need all of my source in my source control. I just need some of my source in my source control. And now we're in a paradigm, if we use them, where I have to pull my source, and then I have to pull from another source and hope that it works. Now, right now, if it's new and fresh, oh yeah, it's working great. But if you go back and just go on GitHub and Splunk around, you'll find some samples, some sample projects that are published online that somebody produced a sample. Maybe it was even some open source sample projects. And pull them down and try to compile, and guarantee you will find one that will not compile. All you did was clone it and pull it down and compile. It won't compile. Why is that? It's because some of the nodes in the graph of dependencies that NuGet pulled in are a different combination of DLL versions than when the last commit of that sample was put there. It happens with NuGet. It happens with Node NPM. It's just the way that they're set up. Because if you take on a dependency that has a greater than or equal of another dependency, right then and there you are introducing a variable where you're saying, it's okay if you give me something different at some point in the future. So if you depend on NuGet package A, which depends on NuGet package B, which depends on NuGet package C, NuGet package C down the line makes a breaking change and revs, and now you get it fresh. Guess what? You have a different version. So when you do this, now on day one you're fine, but months down, and definitely by the time the original developers leave, it could happen by the time you have the third developer in the third month. Somebody's going to pull it fresh that hasn't been pulling it every day. And the mix of libraries is going to be pulled in, and it's going to be a little bit different. And that's when you won't have any idea what happened, because your source control repository doesn't have any record exactly of what version mix is required. Okay? So it's not hard to prevent that problem. You just commit the packages folder, and you're not going to get into a hard drive space problem. And even if you do rev these a lot and you don't want every version, Git has a shallow clone feature where you can say, you know what, I don't need to clone the whole thing. Let me just clone the last 30 days and I'm fine. Give me a shallow clone, let me go. So I wanted to sidetrack on that because it's one of the issues. If you do a Google search, the Node community is wrestling with this problem the same way because it's just part of using a package manager, and it's a problem that I'm not sure that architecture can actually fix. We need a mathematical proof that if I go back in time, I have exactly what it was yesterday, last week, last month. That's what source control gives us. It is absolutely impossible that I don't have exactly what it was a month ago. And if we use the package managers just by default with the default configuration, we lose that mathematical proof. Okay. We want to include everything else. I'm going to go into that. Azure Resource Manager templates, database schema migration scripts, absolutely include everything.
For you. If I get that, you mean you encourage to checking the packages, for example, for .NET project and build modules for another project into your repository and reference them?
With that method, you guarantee that when you go back in time, you will always be in a stable state that you were. That's the only way to get that guarantee. All right. Okay, Visual Studio is in the mix. I'll come back to application insights because we can integrate that really easily. Now, local private build that I've talked about, I'm going to blaze through here and get on to the continuous integration build. And besides building and just running tests, notice that I have embedding version numbers in assemblies. That application info file, we poke in those version numbers, and then static analysis, which I'll come back to. Then we push to the built-in NuGet server of VSTS, and that way we have every version that we need to. And then our first line environment is an automated test environment. I'm going to pause, and I'm just going to jump over to VSTS. And I'm going to show you the application that we're working with just to make it real. And for those of you who are online, you can poke around for a little bit. Here's my dashboard that I have. Here's some live stream metrics, which I'll turn back on. And I'm going to go to releases. No, I'm going to go to builds. So I want to show you some monitoring data. So I'm actually going to run a build. And my build is called load test. So essentially for about, I don't know, 6 or 7 minutes, I'm going to just generate traffic so that I have traffic going, so I have some live metrics. In the meantime, I'm going to show you what this application does. And you guys can go to this URL as well. It's cmbootcamp.prodweb.clear-measure.com. And you can log in because we've kind of configured it as a sample there if you're interested. And I'm going to log in, and it's a simple expense report system. And at the bottom here, we have just some information that we're printing out to the screen. It's version 4.0.23, the environment name, what machine, what it's on. This one happens to be production, and you want somewhere in the application, maybe a hidden page or something, where you can go on any environment and just see, hey, where am I? Does anybody use BG Info from sysinternals on servers by any chance? Because when you remote desktop in, you see, it's like, okay, where am I? It's really handy on the desktop to see what server name and all that stuff. It's the same thing with the deployed environment. When you have multiple of them, when you pull up the application, you want to be able to know really quickly, where am I, and not have to guess. Okay? So expense reports, that's it. You can just click around. And so I'm sending traffic here so that we have live metrics that are going to pop up in probably about 4 or 5 minutes since we've started this load test when it starts up. Okay. And if I go to releases, we can see that we have 3 environments implemented. I'm going to show you the Azure PaaS environment. And so test, staging, production is queued because I manually approved that one. But I just pushed one about an hour, 55 minutes ago. And we are essentially, who's used this before, by the way? Am I talking to people who are really familiar with this? Who has never done an automated deployment with this feature of VSTS? Never done it? Most of you? Okay. Just wanted to. So it's really interesting that we can see exactly what happened. And if I go and say, okay, I'm going to do a UI deployment, I'm going to create my website, it pulls open the logs, what ran on the server. And I just clicked on the step where it used an ARM template in Azure. By the way, I'm intentionally not poking around in the Azure portal because, I mean, that's the easiest way to get started, and invariably everybody in here has done that. But I'm showing the command line way and the command line scripts because in a DevOps pipeline, we implement all of this by executing commands. We don't want to with our fingers and mouse go into Azure and create these things in a bespoke way. So if I zoom in, we can see that I am essentially running an ARM template, and this is the standard output from an ARM template, where the file, if we look on the drive, UI-40112.0, which is the version that we're in, website arm.json. That's the Azure template, which I'll show you the contents of in a minute. And any warnings or errors, this demo's had so much changes to it. We just leave in errors because it's in real life. And then successfully deployed the template and created a test website. Okay, that's good. Then the next one is UI deploy, where we copy all of the files. And so we can see that there's a bin folder. We're calling MS deploy. There's the views for an MVC web application. There's the application insights JSON file. There's a bunch of DLLs that we're deploying. So you can see that we're deploying the application. Now let me go to Visual Studio real quick and just show you the contents of the website ARM JSON. Now, I really haven't met anyone who looks at here and just natively reads this like you read English, because they're pretty cryptic, and they are. And so you can take a template and you can kind of tweak it, or you can go to Azure, create a new resource, and then click on the button that says Export ARM. That's how you get. Do not create this from scratch, okay? But we can see some of the. Let's see. Worker size. Here's one that everyone will recognize. If I wanted to have more than one workers, then there's where the number of workers is set. So if I wanted to have, web 2 or 4 or whatnot, I could poke that in or I could elevate that to a parameter. So everybody will recognize that. Now, there's also a SQL Server database. So naturally, there would be a database ARM template. This is where we create our Azure SQL Server and the SQL database, because we need to create everything. So look at this. Database login password. You guys would recognize that if you're setting up a SQL Server, and what the variable names are going to be. So there's the database server name. And in VSTS, if we go over here, let me just show you the order in which we do things. We obtain the database package from NuGet. Okay, so let's look at the logs. What are we doing here? We are starting the download from the NuGet server, and we're downloading database.zip. Okay, which, by the way, NuGet now it supports the nupkeg version, but also supports zip. And then we obtain the package, we create the test database, which we pass in the resource. We make the resource groups for environments unique. Okay, so there's our resource group, and there's our database arm.json. I'm not going to go through each one of these, but once we do that, we create the database schema. Now, this is interesting because you're going to have to do this if you don't have it already. Look at what we're doing. We're saying we're going to update the database name, which, look at this. The database name in our test environment is a label that makes it really clear which version number and which environment this goes through, because we're going to throw it away at the end of this build. On database server, auto-generated something, .database.windows.net. And these are the scripts that we are running in order. We're using a database migration tool. This happens to use AliSQL, but you can use Roundhouse, you can use Redgate ReadyRoll, you can use DACPack, whatever tool you need to, as long as you have the feature where you execute scripts in order. And this is important, to execute scripts in order. Because if yesterday a phone number column was split so that you have area code and then the rest of it, and then you go in source control to last week, and you run your build because you need to hotfix something because it's in production. You go to last week. You need to pull it down, and you need to have the mix, the sequence of scripts, that when you run it for testing your hotfix, you're creating the database schema exactly how it was last week before you split the phone number column. Now, there are some tools that look at the target environment and say, I'm going to figure out how to make it go from what I want it to be from the target environment. Well, in simple scenarios, you might be able to do that, but where you destroy data, you just fundamentally can't do that. And so if there was like a phone number split, how is it going to say, oh, I need to put those together and then let me re-put parentheses or whatever it was that we parsed out, okay? So that paradigm of tooling doesn't give you the mathematical proof that you can always go back in time. So you always want to preserve the absolute guarantee that if you go back in time, you can always get to exactly what it was. So that's the DevOps mindset, how you think about how to configure these tools. Do you have a question, sir?
Yeah, so, I mean, one of the things I can't get my head around this paradigm is slot deployments.
Okay.
We basically are kind of leaning towards NoSQL because that would handle slot deployments better, but I don't know if you've attempted to do slot deployments with a SQL database and how successful that would be.
Yeah, so whether it's a slot deployment or the reality that a lot of legacy systems do have two applications or even two components that are versioned separately that have the connection string to the same database, I think it's the same problem. You can't, if you have a true microservice where the application, the service, owns its data store, absolutely owns it and nobody else touches it, if you have the microservice and atomicity or autonomous, then you're fine, you can just do what you want to. But so many times you have two applications, two running processes that have a connection string to the same database, and one's going to version for the other. And of course, if you're trying to deploy in the middle of the day, in your development of database changes, you have to say, okay, I'm going to only do backwards compatible changes. Meaning, and one of the techniques is I'm going to create a new column, and I'm going to create a trigger from one to the other so that my two versions can be running at the same time against this transitionary schema change. And then once I have the second application or second service fully updated, then I can come back in a subsequent release and I can remove the column that's no longer used. In the continuous delivery book, there is a chapter on databases that does talk about those things. And it's not that any tool is ever going to do automatically for you. It's a paradigm where you realize, you know what, I've got independently deployable applications. They have a shared database connection string because of historical architectural decisions, and I have to make backwards compatible database shifts. But that's a real issue. Okay, so let's get back here and let's bring this home. Okay, now, this first automated testing environment. Actually, let me just show you one more thing. In our deployment, let's see. Well, here's the dashboard, and you can see that I have test, staging, and production. Okay, test is a no humans allowed environment because as new builds run, I'm going to automatically deploy this thing and run some full system tests, and I'm going to destroy the resources that were in Azure. So if anybody's trying to be on that environment, it's just going to get pulled out from under them. So this is one where it's an extension of the continuous integration build because some test suites, certainly Selenium test suites or anything full system test, has to be run against a fully deployed application. It can't be run just against libraries like perhaps in-unit test can. then staging is, okay, that's my human environment. Now, staging is a human environment. You could split that into 3 ways. Some people like to have one called QA. Then they like to have one called UAT. Then one called staging. But the type, the environment type is a persistent human environment where we preserve all data. Okay? Whereas the test environment, no humans allowed. Everything provisioned from scratch, including the database, including the test data set, and then afterwards it's thrown away. We just delete the resource group in Azure. Staging is persistent because we have to have one of those, at least one of those, before production, because production is persistent. Okay? And so everything that we do in a production deployment, we have to have done and prove that it works in an environment before production. So staging environment's always there. We do non-destructive database schema changes. Of course, if something's broken, it'll break there. And anybody that's testing it that has certain customer sets set up and whatnot, well, the data stays there. In production, it's just like staging, except everybody else is using production. So we have these 3 environments, and those are the environment types, and that's the model for progression of environments in DevOps. But for the test environment, there's one key thing. And that is, at this point, you want to make sure that you have the mechanism in place so that you have a chance to get to 95% defect removal. We all want high-quality software. We don't want to ship bugs into production. When we change things, we want the software to get to production and not have problems. Now, the research has shown, and if you're interested in numbers, you can come talk to me. Capers-Jones is our most prominent industry statistician that is still going strong in consulting and writing books. He's kind of aggregated lots of various research. But for testing, we have automated testing, we have manual testing. That alone only gets you in the 30% of defect removal. And a lot of you can probably anecdotally say, yeah, we test, but we still have problems that get through. Then inspections get us above the 50% mark, where if you do pull requests, where somebody's actually, and code reviews where somebody else is going through, maybe you have a checklist of things to look for, and is looking at what someone else changed. That's an inspection, okay? That helps too. When you add testing and inspection and static analysis, that combination gets you to that 95. Or that combination is the only combination that research shows that gets you to 95. That you're not going to get to 95 without, at a minimum, those 3. Okay? And if you adopt those 3, you'll get there. Static analysis is tools like Independ or the Visual Studio Analyzer, and there's others out there for things like, do I have any methods with off-the-chart cyclomatic complexity, or do we have any fresh dead code that was just inserted, or did our code duplication increase above some small threshold? It's these analyzers that can analyze and just fail the progression of that release candidate if we get to a certain point. Do you have a question, sir? Okay. And let me show you, and by the way, this sample, if we fixed all of the warnings in this sample, it'd be kind of boring. So let us show you the product of a build. Let's see. Let's go to this latest build and show you the dashboard with what we're talking about. So I'm gonna. All right. So this build completed, and of course we have some automated tests. That's great. Then we have some code coverage, where we have 57.41% code coverage. By the way, I'm probably never going to work in a software project that has 100% code coverage, because we choose to not cover our controller action methods with in-unit tests, because they're just 2, 3, and 4 lines of code. They're just mapping, and you'd be just over. They don't provide any value when you adopt an architecture that separates logic somewhere else. And if you get the logic out of your UI, which is a good practice, the controller methods are just, hey, if model state is valid, then go to this view. If it's not valid, then let's get the errors and let's go to another view. And that's the pattern. That pattern works well. So we're not going to get to 100, but you want to look at a line graph of your code coverage over time, and you don't want it going down. Okay, that's why you need to know it. And you can download the code coverage, and you'll get a Visual Studio file that you can double-click in and literally pop you to the line of code. Has anyone ever done this? Who's using Visual Studio code coverage? No? Okay, let me show you this real quick. So there's the code coverage. Let me pull open Visual Studio, and let me drag this guy over to Visual Studio, pop it in there, and then code coverage results is right here. Let me zoom in for you. All right, here's our code coverage results. We have not covered, data access. 0 lines of code not covered. You know what? That's good, because I want every single query at least covered by a test that goes to my database. But I have 140. Okay, .core. Well, let's see. No, that's not interesting. Let's see the 3 things that are not covered here. Oh, expense report fact. Okay, and there's the one that has 3 lines not covered. Let me exit out of here so you guys can see the results. And now it highlights the 1 line of code that somebody put in with an if statement without putting a covering test. Then we had this logic completely covered, but then somebody put in, boom. And this is not covered by any of our automated tests. So the library in this namespace was pretty good, but somebody along the way was in a hurry. And that's the line of code that we thought in a certain section of our application would be covered, and it's not. Okay, so it gives us visibility, and it's easy. You just hook it up one time, and then from then on, if ever something happens, you just dig in. It's like, boom, there it is. Obvious. Okay? Who thinks this might be useful? Okay. All right, then we have Independ doing static analysis. And it really easily shows you a technical debt percentage and said, oh, this application's a C. We give it a C. Now, of course, it's against a set of rules that you can customize. But it gives you something like, you know what, based on how big your application is, I think that if somebody worked on it for 1 day and 3 hours, which is like 11 hours, if somebody just worked on this for 11 hours, you could get it to a B. You could fix the problems that we deem graded as C, and you can change that. Or you can go to the detailed report. I'm not sure if I have it hooked up here. We'll see. No, it redirected me wrong. But anyway, it gives you kind of the high level. All right, let's go back. So in VSTS, Independ is a third-party product that is in the marketplace. And so you can just search for it in the marketplace and, hey, give it to me. And they'll say, give me a bunch of money. And you say, OK. And then it kind of puts it in there. And, all right, but the important part here, if we're gonna deploy quicker to production, we don't want to create a better and more efficient defect delivery process. We want to put things in place that squeeze out the problems before they get to production. And so your testing, whether it's manual or automated, plus inspections, pull requests is a great way to do code reviews, and then static analysis, which with a tool like Independ, you put those together, and you're going to set up your process for high defect removal, which all of your users are going to love you for. Okay, so that's an important part of the DevOps model. The staging environment, I've already covered this, but this environment is going to be the same size as production. So if you want to do some load testing or some capacity testing where you really hammer it using Visual Studio's load testing capability, you would do it in this environment as a one-off. And then production is you just deploy, you do the smoke test. Now let me talk about the smoke test concept. All of you probably have some IT tools that where you give it a URL, and there's a tool that constantly pings the URL and says, is it still up, is it still up? And as long as it's returning back a 200, oh, okay, the application's up. But if it ever returns a 404, then alarms go off. Am I right? Can you give me some hands up? Everybody monitor at least that way? Now, a smoke test of a successful deployment should tell you, not only did the web server return, but guess what? Everything is online and functioning as it's supposed to. So how do we get there? There's a few easy ways. You can make a web API controller method, or just if you're in web forms, make an ASPX. And then you have a spot where you can write lines of code. And if you only have a SQL Server database, great. Write a couple simple queries just to make sure that, or write one simple query, make sure the database is there, the connection string was correct, the username that you're running under actually has the ability to query the database, and now you've verified that not only is the web application online with the front page, but also that the SQL Server is connected, ready to go. And if you rely on MSMQ or Azure Service Bus or any of these things, a blob storage or anything where there's a token, a credential, well, now there's all these dependencies, and what if something's wrong? What if a configuration value got sideways? Write a line of code per dependency to just call out, do something simple with that dependency, and now your IT tool that calls that endpoint, you now have a built-in health check where you have proven that all of your system dependencies are online and accessible. And every single time you do an automated deployment, you want to know that, because if you don't get that automatically, what are you going to be doing? You're going to be poking around the application, running enough key transactions so that you know for yourself that you touched every key dependency. Come on, we all do it. You're going to do it. You're not going to say, oh, it's good without doing that, because you've learned. Except for my daughter over there, all of you have felt the pain of somebody coming in the next day or whatnot and saying, hey, you know, some of the application works, but this application just bombs. And then you dig in and realize that one of the dependencies wasn't hooked up right or wasn't turned on. All right. I thought I was going to get some amens after that preaching, but oh well, didn't happen. Okay. So the last thing, and it is in the Azure portal. It is in the Azure portal. If I go, I'm just going to send some requests to these different environments, and then we're going to be done. Is the monitoring. Application Insights is so easy to set up. If I were to right-click on the top level guy, there is literally an item called Configure Application Insights. If you have a .NET application, right-click and click that button, because you get it all for free. Let me show you what you get. You want everything monitored. Let me show you what you get. No, portal. There it is. Okay, so I see my CPU. Oh, did you see me send a request? Guess what? That's that spike. I can do live monitoring that I just sent. Not there. I just sent a request. Enter. And if I go back and click on Open Analytics, now I get Microsoft Operations Management Suite, the new version in Azure, and I get all kinds of metrics. And I'm going to go down and I'm just going to say, show me the requests. And Shift Enter, and it's going to pop open, and I'm going to scroll down here, and I'm just going to pick one recent, and look. Now look at the information that I get about somebody used my application. Oh, this was the URL. And of course, in my deployments and in my tests, I have someone go into a deploy that logs exceptions and does other things. But look at this. Look at this information that I get. The computer that it came from was in Virginia. Well, that was where the Azure data center happened to be that I came from. But I mean, you can use this to map it to a globe of where all your people are coming from. And you right-click, say Configure Application Insights, and you get this. That's it. It'll pull down some NuGet packages. It'll pull down some NuGet packages. It'll create an Application Insights config file where you have to put in your key, right? And then if you're using Log4Net or something else, you come in here and you put and it will put in your Application Insights Log4Net appender so that everything you're writing to Log4Net gets centralized so that you can have someone know what the log files are saying without having to have production subscription access. And then in your web config, you also have some modifications and technical modifications because it wires up the entire application for performance counters and everything else. And so I'm going to leave you with some interesting things you can do just to check it out. You can create a controller that throws an exception, that catches an exception, that creates a custom metric class, and you can try it out. And Application Insights is just going to capture all this stuff, and then you can query it really easy, and you can give someone access to what the application is doing without giving them access to the actual production resources or the production Azure subscription, which, by the way, your dev and production or pre-production and production subscription should be different. not the same. That's a big security boundary. So anyway, that is a walkthrough of the DevOps model with an emphasis on Azure. So I hope that this was useful, and thank you for being here. I appreciate it. You guys have been great.